Section 3.5 is on ratios and proportions. A ratio is a comparison between two quantities using division or two things. If we have circles in squares or circles in triangles and we want to compare the number of circles we have to the number of triangles we have, we can use a ratio. We have 3 circles, 2 triangles. We could choose to use colons for that comparison or division or fraction for that comparison. We're going to focus on the fraction comparison. When you have 2 ratios that are equivalent, you can set them equal to each other, and that's helpful if you know part of one ratio but not the other part. For example, if I knew that I needed 18 circles, but I don't know how many triangles I need, I can set this information equal to each other and use a proportion to solve for my unknown. Well, how do you solve for an unknown? Cross multiplication is one way to help you solve for it. Now, we've looked at other ways to solve fraction equations, and you can use those methods by multiplying by your LCD, or you can use cross multiplication. Cross multiplication is kind of what it sounds like. You multiply across. So you're going to multiply diagonally across the equal sign. It's one of the few times we kind of go across the equal sign like that and multiply those numbers. So this 3 would be multiplied by our variable, and the 2 would be multiplied by the 18. And in my classes, we tend to kind of think about this to help us remember as like little butterflies. And you can do that too if you want. It's up to you. But in this video, I'm just going to highlight, because that's a little bit quicker and easier with this app that I'm using. So for this first example, the blue that's highlighted will be multiplied against each other. And then the green, 10 and 24, will be multiplied against each other. Well, 16 times x, that's just 16x. And then 10 times 24 is 240. And then now I have a one-step equation, goodness, which is going to give me x equals 15. For this next one, same process, cross multiplying. What makes this one a little different is that when I go to multiply this blue side, this 6 is being multiplied by both numbers in the numerator, which means I need to use the distributive property. That distributive property will make sure that I multiply the 6 by both numbers on the inside, or by both numbers in the numerator. And then I can do my steps to solve the equation, getting that x equals 12. In some situations, your proportion is given to you as a word problem, and you need to pull out the information to help you create your proportion. This one says the property taxes on a 1,100 square foot house are $2,717 per year. Assuming the taxes are proportional, what are the property taxes on a 1,200 square foot house? And then there's some additional information down here. It says assume property taxes on a 12,000 square foot house is $T. Write an equation to model this scenario. And it says there's no need to solve it, but we're going to go ahead and solve it. So the first thing I do, it's already identified the variable for us. So the first thing I'll do is pull out my information for the proportions. I need to have two ratios in order to create my proportion. And the ratios compare things. So here, it's giving me information about the square footage of a house compared to how much property tax it's going to have. And this is the larger house. It's going to have 1,900 square feet to $2,717. And then I have a smaller house. Next thing I need to do is figure out how I want to set up my proportion. And there are two ways that you can set up your proportion. The first way is to create your ratio using the houses as your ratio. So this is already written as a ratio, as you can see with the colon here. So I can just create this as my first ratio, which would make this my second ratio. So we have the blue part as my first ratio, and then the green part as my second ratio. So that's one way to create your proportion. Let's go ahead and solve this one. This is going to give us a fairly large number. So I'm going to go ahead and just put that. We are going to put that in a calculator. So we're going to go ahead and do 2,719 times 1,200 divided by 1,900, and we'll get 1,716. Now, there is a second way to write the proportion. This first one, we use the ratios of the larger house versus the smaller house. However, some people may see a different proportion here or a different ratio here, and there is a second ratio in which you could write. You could choose to write your ratio based on the units rather than based on the items being compared. So I tend to write mine based on the items being compared, but you could write your ratio based on the units of the things you're comparing. So if you choose to write them based on the units, then you would have a proportion that looks like this. And when you cross multiply, I want you to notice that the blue highlighted is the same here as it is here. And the green highlighted here is the same as it is here. The only difference is the green, the numbers are in different positions. But when I multiply them out, this is going to give me the same as that. And so my answer is still going to be the same answer. And so you can write a second proportion. There are two options on how you could write this proportion. Now, if I were to try and mix and match on my proportions, you're going to end up with the wrong answer. You need to have the items ratio together or units ratioed together. So let's look at one more example. And we're going to remind you items ratioed together and units ratioed together. So for this one, Corey makes $116 every 8 hours he works. How much will he make if he works 32 hours this week? Well, we have a ratio here for a shorter shift. We're going to say the shorter shift. And that's going to be $116 for 8 hours. And we want to know how much is he going to make in 32 hours. So this is a longer shift. We don't know the money, but we know there's 32 hours. Now this is going to have an unknown because we don't know this number. So let's say the unknown is M. And since they didn't give us that unknown like they did here, they told us our unknown was T. They did not give it to us here, so we need to identify it in our problem. Let M be the amount of money earned. And I can create my proportion using the longer shift versus the shorter shift, or money versus hours. That's up to you. As I mentioned, I like to compare items. So I'm going to do shorter shift versus longer shift. So I'll have 8M equals 116 times 32. 116 times 32 is 3,712, which gives me M equals $464. So Corey will make $464 for a 32-hour shift. And that is solving proportions.